So in this video, we're going to be talking about graphs of kinematics. That means the angular position versus time, angular velocity versus time, angular acceleration versus time. Again, very similar to what we did in Unit 1 kinematics. So we're going to reuse a lot of those skills, but just apply it into the rotational form. So similar to rotational kinematics, we always had graphs of those motions. And just as a recap, just a review, remember you always look at the y value, and then the slope is always the change in the y variable over the change in the x variable, and the area is the y variable times the change in the x variable. And so similar to linear kinematics, if I have a position versus time graph, the slope is going to be the angular velocity. If I have angular velocity versus time, the slope is the acceleration. The area is the angular displacement. And if I have an acceleration versus time graph, the area is the change in angular velocity. So exact same thing we did in the 1D kinematic and graphs of motions. We're just going to kind of quickly summarize it because it's very, very similar and identical to what we did before. So graph shows the angular velocity. So we have omega versus time. And so always we start with here, the y value is the angular velocity. The slope is the change in the angular velocity over the change in time, and that is the angular acceleration. And the area is the y variable times the change in the x variable, and that is our angular displacement. So it shows angular velocity as a function of time. It starts at 30 and goes to 0 over the course of 5 seconds. Find the angular acceleration and use the results to kinematic equations. Well, the slope is going to give us the angular acceleration. So the angular acceleration, just pick 2 points. This is 0, 30, and this has the correct units. This is 5, 0. So it's going to be 0 minus 30. This one minus this one over this one minus this one over 5 minus 0. And that's going to give you negative 6 radians per second squared. Now, why can we use kinematic equations? Well, the angular acceleration is constant the whole time, so we can list out our kinematic variables here, and we say like, well, I don't know the angular displacement. Initial at time 0, we're going 30. We're going to end at, say, 0 after 5 seconds, and the angular acceleration is what I want to find. And then the kinematic equation we use for that is omega equals omega naught plus alpha t. We would just say 0 is equal to 30 plus alpha times 5. And so alpha, move that over, divide by 5. You're going to get negative 30 divided by 5, which is negative 6 radians per second squared. Now, remember, we can only use the kinematic equations if the angular acceleration is constant, okay, so which it was in this case. Find the angle through which the propeller rotates during these 5 seconds. So that's the angular displacement part, right? And so we're going to use the area here, and we will use the area of this triangle. It's going to be 1/2 the base. Base of the triangle is 5. Height of the triangle is 30, right? And so it's going to be 75 radians if we do that. All right, 15 times 5. Okay, now we can find this value. Going back to our kinematics, can we do the same thing? Well, let's use this equation. I want to use something that's not like identical to just this calculation. So we use the omega naught t plus 1/2 alpha t squared. So that's going to be 30 times 5 plus 1/2. We got negative 6 for the alpha times 5 squared, right? And if you need to pause it and just go through the math, but minus 3 times 5 squared. Plug it in, I get 75 radians here. So exact same thing as before. Sometimes the area, it might be a curve, so the area, or it might be a bunch of different straight line segments, just like we did in linear kinematics practice. If you found this video helpful, come check out our school community. It's got an amazing bunch of features. It's got extra videos, corrected videos, better than the ones that I have errors on YouTube. It's got multiple choice free response questions. I hold live Q&A sessions and go through more problems and and I answer students' questions, help with schoolwork, all kinds of things. If you want to check it out, look in the description below, or check out the website and find us in the school community. You get a 7-day free trial to give it a shot, just to check it out, see what it's like, come join some calls, and honestly, come learn AP Physics 1 even faster with us.